Hello everyone. In this lecture, I will be discussing about registers. Register is a group of flip-flops which is used for storing binary information. A flip-flop is a basic memory element capable of storing 1-bit information. An n-bit register consists of a group of n flip-flops capable of storing n bits of binary information. In addition to flip-flops, a register may have combinational gates. The flip-flop holds the binary information, and the combinational gates determine how the information is transferred into the register. Registers are mainly used for storing and shifting the binary data. A register that is used for storing the binary information is called memory register. A register that is capable of shifting its binary information in one or both directions, that is either from right to left or from left to right, is referred as shift register. The structure of the shift register is shown in the figure. The logical configuration of the shift register consists of chain of flip-flops connected in cascade. The output of the one flip-flop is connected to the input of the next flip-flop. All the flip-flops receive common clock pulse. It activates the shift from one stage to the next stage. In the shift register, the data can be entered serially or the data can be entered in parallel. Similarly, the output can be taken in serial manner or in parallel. Depending upon the data input given and the output taken, there are different types of shift registers. In the serial in, serial out shift register, the data is entered serially, that is by bit, and the output is also taken serially. In the serial in, parallel out shift register, the data is entered serially and all the outputs are taken simultaneously in parallel. In the parallel in, serial out register, the data inputs are entered in parallel and the output is taken serially. In the parallel in, parallel out register, the data are entered parallel and the output also taken in parallel. In the serial in, serial out register, the data is accepted serially, that is one bit at a time on a single input line. It produces the stored output on its single output also in the serial form. The output of the one flip-flop is connected to the D input of the next flip-flop. This register, it is unidirectional. That is, the data can be shifted left from lower to higher order bits using shift left register, or the data can be shifted to right, that is from higher to lower order bits using shift right register. For each clock pulse, the data stored in the register is shifted to the left by one stage. This register, it requires n clock pulse to store n bit word. The operation of the serial in, serial out register is shown in this figure. Initially, all the flip-flops are in the reset state, that is all the values are set to 0. In the first clock pulse, the first data is entered serially. So this data is entered to the first flip-flop, and here this 0 in the flip-flop is shifted here, and 0 from this flip-flop it is shifted here, and 0 it is shifted here. In the second clock pulse, the second input is given. 0 is entered to the first flip-flop and the 1 here it is shifted here, 0 shifted here and 0 here it is shifted here. During the third clock pulse, the next input data it is entered serially. So 1 it is given as the input for this flip-flop and 0 it is shifted here, 1 shifted here, 0 it is shifted here. And during the fourth clock pulse, the next data 1 it is entered to this flip-flop and 1 here it is shifted here and 0 shifted here and 1 here shifted here. So it requires 4 clock pulses to store 4-bit word. So in the serial in serial out shift register, the only Q3 output is available. In serial in parallel out shift register, the data is entered serially and the output are taken in parallel. The operation of the serial in parallel out shift register is similar to that of the serial in serial out register. The only difference is that here all the output are available simultaneously. Q3, Q2, Q1, Q0 is available simultaneously in parallel. In the parallel in serial out shift registers, all the input bits are entered simultaneously into their respective flip-flops. The output of the previous flip-flop is connected to the next flip-flop through the combinational circuit. The binary input is also applied to the flip-flop through the combinational circuit. Here D0, D1, D2, D3 represents the data input. And there is a control signal shift/load bar. So this signal decides the operation of the register. So depending upon this value, there are two modes of operation. In the load mode, the control signal shift/load bar, it is 0. So in this mode, the parallel loading takes place. In the shift mode, the control signal shift/load bar, it is 1. And here the shifting of data from left to right takes place. So in the load mode, the control signal, it is equal to 0. Since the control signal is equal to 0 here, so output of the inverter it is 1. So the 2, 4 and 6 AND gate will be active and the data D1 will be entered to this flip-flop and the data D2 will be entered to this flip-flop and the data D3 is entered to the flip-flop. So here the parallel loading of input takes place. In the shift mode, the control signal shift/load bar, it is equal to 1. So the signal it is equal to 1. So here 1, 3 and 5 AND gate will be active. So in this case, the output of this flip-flop Q0 is connected to the next flip-flop. Similarly, the output Q1 is connected to the next flip-flop. Similarly, Q2 is connected to the next flip-flop. Here, shifting of data from left to right occurs on the application of the pulse. Thus, the parallel in serial out operation takes place. In the parallel in parallel out register, all the input are given simultaneously and all the output are taken simultaneously in parallel. So in this register, there is no interconnection between successive flip-flops since serial shifting is not required. The moment the parallel entry of input is done, the respective bits will appear at the parallel output. In this case, only one clock pulse is required to load all the bits. So in this case, the data input is 1010. On the application of the clock pulse, all the data will be simultaneously available at the output. So at the output 1010 is available simultaneously. Similarly, the next data 0110 applied during the next clock pulse will be simultaneously available at the output 0110. So universal shift register. So before starting with this universal shift register, so we'll see what is unidirectional shift register. So in the unidirectional shift register, shifting of data takes place only in one direction. In the bidirectional shift register, shifting of data takes place in both the directions. A shift register that can shift data in both the directions as well as load it parallelly is referred as universal shift register. This register consists of 4 D flip-flops and 4 4-input multiplexers. So the diagram shown here, it consists of 4 flip-flops and 4 4-input multiplexers. S1 and S0, it represents the selection input of the multiplexers. So this S1, S0, it is used to select one of the 4 input of the multiplexer. When S1, S0 it is 0, 0, the input 0 it is selected. When S1, S0 is 0, 1, the input 1 is selected. When S1, S0 is 1, 0, the input 2 is selected. When S1, S0 it is 1, 1, input 3 it is selected. So these selection inputs, they control the mode of operation of this register. So this it is given in this function table. When S1, S0 it is 0, 0. The input 0 is selected. So here the present output of this flip-flop is given as the input for this flip-flop. Similarly, the output of the flip-flop is given as the input for this. And similarly, the output of this flip-flop is given as the input. Output of the flip-flop is given as the input for the flip-flop. So therefore, there is no change of state occurs. When the selection input S1, S0 it is 0, 1. The input 1 it is selected, that is the serial input is given to this flip-flop A3 and this A3 is given as the input for the next flip-flop. Similarly, A2 is given as the input for the next flip-flop and A1 is given as the input for the next flip-flop. So, shifting in the right occurs. When S1, S0 it is 1, 0, input 2 it is selected. So, serial input for this A0 register it is given. Here in this case, here it will be shifted right. So, this output is given to this register. Similarly, the output it is given to this register. So, output is given to this register. Here, shifting in the left direction takes place. When S1, S0 it is 1, 1, the binary information in the parallel lines, that is I3, I2, I1, I0 is transferred to the registers simultaneously during the clock. Thank you. Happy learning.